And welcome back. It's the Four Sigmas, Alex speaking, and with my lab group today. So today we're going to do the second half of the photoelectric effect lab. This lab talks about stopping voltage versus light intensity. So what we're going to be doing is varying the aperture to let more or less light through and seeing what effect that has on the stopping voltage at the same wavelength of light. So I'm going to bring up our front-facing camera. It's new today, so you can actually see what we're doing in the lab. So as you can see, we have our mercury lamp set up with our current amplifier and our power supply. So first things first, I'm going to ask Chris to calibrate our amplifier. So he's going to press the button in, make sure it's zeroed, and then release the button back out to get us ready to measure. And awesome. Right at 0. So what we're going to do now is we're going to start at the 2 millimeter aperture with our 436 nanometer wavelength. And Ryder is going to take the cap off of the mercury lamp. And you can see that our current just jumped up, so Chris is going to adjust our stopping voltage accordingly to get our current back down to 0. And as you can see, it takes a little bit of a fine touch, but you'll get it. Awesome. So as you can see, that stopping voltage is negative 1.283, and that's going to autocorrect to 1.28 in our table here. So now we're going to cover the lamp and change our aperture to 4 millimeters. At the same wavelength of 436 nanometers. And we're going to uncover the lamp, and we're going to see what effect that has on the current. And as you can see, we're getting about the same stopping voltage. So we're going to record that on our data table, a 1.246. Again, that corrects to negative 1.25 in our table. And we're going to lastly cover up the lamp again, change our aperture to 8 millimeters, and keep the same wavelength, uncover the lamp again, and see what happens to our current. And as you can see, it's almost exactly the same. Is exactly the same. Negative 1.246, which autocorrects again. Now, you might be asking, why is the stopping voltage the same on all three? Seems like if you let more light in, the stopping voltage should increase. Well, that's where classical physics kind of breaks off and we get into modern physics. So, what does the result indicate about the relationship between kinetic energy of the electrons and light intensity? That's for you guys to figure out. And in our next video, we'll do the next sections of this lab, which have to do with more light intensity experiments. Thanks, and have a great day. And welcome back. This is our second part of the photoelectric effect lab having to do with light intensity. Now we're going to talk about how the current change is when the light intensity changes. So we're going to start off with our aperture set to 2 millimeters on the 436 nanometer wavelength. We have our ammeters zeroed out, and we're going to uncover the lamp there.
Change the scale.
And yes, as you see in the instructions here, our scale is set to 10 to the minus 12, which is why over here we change it to picoamps so we can actually see the data change. Otherwise, it's going to look really, really close to 0 if you just have it on the amps scale. Now what we're going to do is first of all, I'm going to show you guys our setup real quick here. As you can see, we have it set to negative 4.5 volts, and we're on the negative 4.5 to plus 30 volt range on the power supply. That's important because we're going to go up to plus 30 when we're collecting our data. So I'll get rid of that so you guys can actually see our graph. And I'm going to move me over here. So we're going to be in preview mode, as you guys can see down here. And when we start collecting data, you can see we're at about negative 4.5 volts, which is what we expect to see because that's what we have on our power supply there. So I'm going to go ahead and take this initial value and keep it, and we're going to go in steps of 5 volts. So Chris is going to change it to 0 volts. That's a step of 4.5, but after this we're going to do steps of 5 volts. And so you can see the current has changed. So we're going to keep that sample, and then Chris is going to change it to plus 5 volts. And you guys can see that the current is increasing as we increase the voltage. Awesome. Now we can see it's stabilized, so we're going to keep that sample right there. We're going to go to plus 10. And if you guys want to do smaller steps on this, that's totally great. We're using 5 volt increments just to cut down on like this video. So I'm going to keep that sample right there at plus 10. If you use smaller increments, you might get a little bit of a more well-defined curve. And now we're at plus 15 volts. So I'm going to keep that sample. And now we're at 20, and we've kept that sample. I'm going to go up to 25, and you guys can see that it appears to be asymptotically approaching a point, and that would just be the maximum current that this light intensity would give us. So we're at 25 volts now. We're going to keep that sample, and last but not least, plus 30, the top end of our range on the power supply. And we're going to keep that data right there. Now, what we're going to do next is we're going to change the aperture to 4 millimeters. Now, since we ran this experiment already, we actually know that this is going to max out the scale on our amplifier. But we can show you the first couple points, and you can draw your conclusions from there. And we're going to preview our data run now. We're exactly where we started, which is exactly where we want to be. So keep that sample and move up to 0. And you can see that the amperage is dramatically increased from what it was on our 0 reading in our first run. Now that we've increased the size of the aperture, letting in more light. We're going to keep that sample, and we're going to go up to 5 volts. And now you can see that this reading is higher than even the plus 30 volt reading at our last aperture. So we're going to keep that sample, and from our previous experimentation, we know that when we get to a little over 8, we actually max out our scale. Right here. This is about where we max out our scale, so we're going to keep it right there. And this is what you guys are going to base your data off of. You're going to draw some conclusions on why this occurs. We're going to stop recording, and we're going to go to our next slide. And as you can see, we have both data sets on the graph here. So how did the current change when the light intensity was increased? And was the stopping voltage different for different light intensities? How does the kinetic energy of the electron depend on the light intensity? Those are your questions, and Thanks for watching. We'll see you in the next video.